The previous lectures covers the execution flow of system call by running ecall instruction. Now in this lecture, we will practice debugging the ecall instruction in the TRACE32 debugging program. Then let's start with this debugging environment. So first window you're looking at is the register window in TRACE32 debugging program. In this window, the set of general purpose register can be observed. The RA register, SP register, and the S0 registers. Those are the general purpose register in RISC-V architecture. And another window is the instruction window. The instruction window has the two important information. The first thing is address. The next one is assembly instruction. And another important environment of this debugging practice is that the privilege mode is user mode. Please look at this. The user mode and the program counter is pointing to this address. This virtual address is 3FAF. So this is the typical pattern of the virtual address in the user mode. Now let's figure out some of the debugging, some practice scenario right now. So I'm going to run the ecall instruction, and you're going to find out that the two operations and two key observations can be identified. First thing is, you're going to see that the privilege mode will be changed from user mode to supervisor mode. And then another observation will be the program counter will move to the address of the trap handler. Next thing we can observe is the S cost register. Supervisor cost register is updated to 8 because when running ecall instruction, the value of the exception code that correspond to the ecall in user mode is 8. Now, so I'm going to run this instruction. So I'm going to click this one. So by running this instruction, another important information is that A7 register is updated. Before the ecall instruction runs in the user space, so usually the A7 register can be written with a system call number. In this debugging practice, system call number is 0x40, but in the decimal format, this is the 64. Now I'm going to run this instruction. So here we go. 1, 2, 3. So please look at this. The current privilege mode is supervisor mode. So please look at this icon. This shows you the current privilege mode is supervisor mode. And another important message is that the program counter is in the kernel space. So this is the typical pattern of the virtual address in the Linux kernel. If the Linux kernel is running in the RISC-V, the base system, the virtual address starts with this kind of pattern. Now we will check out another important debugging signature, that is about the value of supervisor cost register. For this, I will navigate the menu from CPU to peripheral. I will go to this menu. Then I will click supervisor trap setup. Then so I will check another control status register. So please look at this. The supervisor cost register has 8 value because the 8 is corresponding to environment call in user mode. Another important signature is that STVAC control status register has this address. So because this control status register has this address, the program counter moved to this address. This value is the same as this address. Now, let's revert this instruction. So as you can see, so we will go back to the state before running ecall assembly instruction. Now, the privilege mode is user mode because I use this command, r.undo command. So this command, this r.undo command is supported by TRACE32 program. So if you are in the situation to debug any assembly instruction, or if you change the value of any of the general purpose register, this command will revert that you are setting of the general purpose register, or it'll to allow you to go back to the state before running some specific assembly instruction. Okay, so moving back to the main topic. Now, for better understanding, we'll modify the value of S-code register. So this value will be updated to 0. Please look at this. So I double clicked this icon, then I will, I type the 0x0. So please look at this. So S-code register has 0 value because I manually enter 0x value. If I double click this icon, this command is automatically updated in this command terminal. Okay, so I will run this instruction again. So by running this instruction, ecall instruction, as you know, RISC-V heart will perform 2 things at the same time. So privilege mode switch to the supervisor mode from the user mode, and then parent counter with the jump to the trap vector base address. Then the relevant control status register, like S-code register, is updated. Another key observation is that this address, please look at this, ecall instruction is placed in this address. So for better understanding, I will modify this value again. This is only for debugging practice. Actually, in the real project, it is impossible to modify those kind of control status register. So by running some of the software, any of the instruction, because we use the TRACE32 the debugging program, you can manipulate any of the control status register for debugging purpose. Now, so let's pay attention to the value in this control status register. So here we go, 1, 2, 3. Please look at this. S-code register is updated to 8, and supervisor exception parent counter registers has this address. And next thing that you can observe is that parent counter is jumped to this address. Now the current privilege mode is the supervisor mode. Okay, so let's roll back again. Okay, r.undo command. Now we are going to perform another interesting debugging practice. So in this window, so one important information we can notice is that this is the value inside STBAG register. So when the trap happens, the parent counters move to the address that is held in this address. Now I will manually modify the value of this register. Okay, so I will change the value like this. Now, so what's going to happen if we run this instruction? Then we can expect that RISC-V heart will move to this address. So let me try it out again. 1, 2, 3. Please take a look at this. Parent counters move to this address. So this address ends with the 2F78. Another important thing we can observe is that the parent counters move to the address that is specified in this register. Okay, so originally that address was this address. When we start this debugging practice, the value of the STPAC register was this address. Now let's revert again. So by running this command alt-undo, then we will change the value inside this register with the original value. Please look at this. By default, before the running equal assembly instruction, by default, that STPAC register has this address. Now, so this register is changed. Now I will run this instruction again. So please look at this. The parent counter jumped to this address according to the based on the value inside STPAC. So based on this debugging practice, so we can observe that the parent counter moved to track back to base address based on the value inside STPAC register. So in this debugging practice, we walk through the important operation. First thing we can observe is that privilege mode switched from user mode to supervisor mode. Now another thing we can observe is that S-code register is updated to 8. So please look at this. S-code register has 8 value. And another observation is that so this register, supervisor exception parent counter register, is updated to the address so where ecall instruction runs. And last important observation is that the parent counter is jumped to the track back to base address when running ecall assembly instruction. So this operation is based on the value inside the STPAC register. So if you walk through all of the steps in this debugging practice, you will thoroughly understand each step that is happened during the generation of exception.